By now, we all know that ChatGPT and other LLMs occasionally come up with bullshit, and sometimes this can have pretty bad consequences. GRATH. GRATH. GRATH? GRATH is the new approach to boost LLM's truthfulness in response to the hallucination phenomenon, which could cause great harm, especially in safety-critical applications. This paper explains how GRATH works and tests it against truthful QA, which has been considered as a mainstream benchmark for measuring the truthfulness of the model answers to the questions that provoke imitative falsehood. Truthful QA contains questions that are designed to provoke LLMs into giving incorrect or misleading answers. It's basically the main verification test to measure the truthfulness of an LLM and compare different models against each other. It consists of two main tasks, MC1, which has one correct answer to the question, and MC2, which has multiple correct answers to a question. LLMs in the real world often encounter questions that are out of domain or OOD. And yes, I'm sorry, but we have to go through quite a few definitions here. Okay, let's write it down and look at it very easy. So we have a certain domain that an LLM is trained on. For example, let's say animals. Then we have out of this domain, OOD. For example, plants. That's a different domain, so it's OOD. Another thing that we want to look at, this is for later on, is we have even further. It's out of the domain, but even further out. So plants is relatively close to animals. Even further out of domain would be, for example, extraterrestrial objects. So let's just write EO. And training LLMs on these OOD questions can be prohibitively expensive and labor intensive. So the paper asks the question, can we effectively utilize OOD queries to improve the truthfulness of LLMs without needing to rely on human annotated answers? And in order to accomplish that, they developed the GRATH process, or gradual self-truthifying, which adaptively generates data using the LLM itself, and then optimizes the model via DPO in a self-supervised manner, without the necessity for any annotated answers to the given OOD questions. Yeah, I know. Why can't anything ever be explained simply for people who are interested in this stuff but don't study it? Well, that's what I'm here for. So one more definition, DPO, which stands for Direct Preference Optimization. And it's way simpler than it may sound. We basically give the LLM a question, for example, what is a hawk? And then we give it two answers. One right answer, animal, and one wrong answer, plant. And then based on these answers, the LLM gives a probability which answer is likely to be right. So let's say the probability here is 0.8. Animal is likely to be right, and plant only 0.2 is likely to be right. By also giving a wrong answer like plant, the LLM can learn better what answer is likely to be right, and it's way more nuanced than just giving a right answer, which is way closer to a realistic conversation. Of course, the hard question is just one example. Good, now that we understand DPO, let's look at how that relates to the GRATH method. I'll give you an overview and then we'll look at it on the whiteboard. GRATH consists of three components. First, creating pairwise truthfulness data to prompt the model to generate a correct answer AT and an incorrect answer AF to any given question Q. Second, self-truthifying. We attempt to learn from the responses that differ in truthfulness, thus enhancing the truthfulness of the model. Since the model enhances its truthfulness by learning from the difference in answer pairs that are generated by itself without requiring any external annotations, we name the learning process as self-truthifying. Third, gradual self-truthifying. Regarding the self-truthified model, as base model, we prompt it to generate correct answers and substitute those in the pairwise truthfulness training data while leaving the incorrect answers fixed. Based on the refined pairwise truthfulness training data, we employ self-truthifying on the base model, i.e. fine-tune the base model via DPO, aiming to improve its truthfulness. You got that? Alright, great, I knew you would. But let's still go through it just for me. The main point is that this process works without human supervision, and the LLM can do it just by itself. You just need to start prompting it with coming up with a right and wrong answer. Let's stick to the hog example here on the board. We already have the probabilities of 0.8 for animal and 0.2 for plant. Now we iterate it. Important, the wrong answer plant stays the same, but the right answer changes and gets closer to the truth. So instead of animal, the new right answer might be flying animal. And now the new probabilities may be 0.9 and 0.1. Then the wrong answer again stays the same. We iterate another time and come even closer to the truth. So now the new answers might be bird for 0.95, and this stays at 0.05. And that's basically how the graph process works. Now, of course, instead of 3 iterations, there are usually, I believe, about 1,000, but this is a process. And it works pretty well looking at the truthful QA. The paper states that it enhances MC1 and MC2 accuracy of Llama 2 Chat 7 billion, elevating them from 30.23% to 54.71% and from 45.32% to 69.10% respectively. And this is massive. So GRATH effectively improves the MC1 and MC2 accuracy with both increased by an average of over 15%. And notably, the 7 billion model's performance even outstrips that of larger scale models, including those with 70 billion parameters. It's also noteworthy to say that next to the truthful QA, there are also other tests for LLM. For example, to measure comprehension, or if an answer is socially appropriate or not appropriate, and much, much more. I won't get into them, but with the ARCC, HELLA-SWAG, and MMLU datasets, LLMs trained through GRATH were maintaining performance on the other 3 datasets. These results again validate GRATH's effectiveness in enhancing the model truthfulness. There are many other LLM trainings for truthfulness, which I will not go in depth into here. But generally, when LLMs are trained on these models, they usually lose scores in the other 3 mentioned tests, which did not happen with GRATH. Another important aspect to mention here is that the model learned by DPO is more truthful in the testing domain if there's a smaller domain gap between pairwise truthfulness training data and testing data. Looking at the whiteboard again, if a model is trained on animals and you ask it questions about plants, it will be more truthful than if you ask it questions about extraterrestrial objects, because this domain is further away, which makes sense, I guess. Good, now let's look at the last definition I have to give you for this paper, which is SFT. SFT stands for Supervised Fine-Tuning, which basically means that you train a model with correct answers manually. You don't give pairs, you don't automate it, you just train it manually by yourself, which is very time and cost intensive. The paper looked at this method and found that the model learned via SFT is less truthful in the testing domain if there's a larger domain gap between pairwise truthfulness training data and testing data. Besides, SFT is less effective than DPO for improving truthfulness. In conclusion, DPO is a more effective choice than SFT for improving model truthfulness. In summary, DPO demonstrates distinct advantages over SFT in these contexts. So it's not just faster and costs less to train the model via GRATH like this, including DPO, but it's also more effective and better for the LLM. So having looked at all of that, the paper demonstrates GRATH's multiple strengths. Effectiveness. GRATH significantly boosts the model truthfulness without compromising other basic capacities. OOD resilience. GRATH could effectively learn truthfulness using OOD questions. Cost effectiveness. GRATH does not require annotated answers to the given questions, thereby reducing reliance on the costly annotation. Efficiency. GRATH achieves state-of-the-art performance on truthful QA with just 2 DPO executions. Mitigating hallucination from LLMs and making them more truthful is an absolute necessity, especially if they should be used for any critical tasks in the future. However, it won't ever be possible to completely eliminate hallucination from LLMs, which another paper has proven. You can check it out how I dissect it right over there.